So what we're going to do now is we're going to focus on single stage completion methods. So these are completion stage methods that are triggered when one previous stage completes. And as you'll see here, there's 4 of these. We're going to look at 3 of them in some detail. The fourth one is really not that widely used. The first of these completion stage methods that are triggered when a single previous stage completes is called then apply. And this is really the simplest one. So as you can see, there's a method called then apply. It's passed in a function action that will be applied to the result of the previous stage. So when the previous stage is done, then this action is going to be invoked, and it's a function. And what then apply returns is a completable future that will contain the result of the action when it's finished. This is typically used for very quick synchronous actions that are going to return a value rather than returning a completable future. So let's take a look at a very simple example. So here we've got a big fraction that we create initially to be unreduced. So we give it a numerator that's a big integer, and we give it a denominator that's a big integer, and we give it a false, which says don't reduce anything. And then we're going to go ahead and we're going to call we're going to create a supplier lambda called reduce, which will reduce the unreduced big fraction when it's called. And then the next thing we do is we go ahead and call supply async, which, as undoubtedly you recall, is a factory method that will start doing the reduction in a background thread in the common fork join pool. And supply async returns a completable future. And when the reduction is finished in the background, that future will then trigger the then apply completion stage method, which just relies on one previous stage to be triggered. And what we're going to do is it's going to pass in an action which will convert the reduced but improper big fraction to a mixed string. So big fraction : 2 mixed string is a method reference that is very quick. It just converts the big fraction that's improper into a mixed fraction. And that doesn't take very long to run. And it's called synchronously in the calling thread where the previous action ran, which of course will be one of the threads in the fork join pool. So that is the then apply method. So the key thing to remember about then apply is it's really intended for quick synchronous actions that don't run in the background. This gets a little tricky when we talk about then apply async, which will run those actions in the background, but we'll come back to that in a second. Let's talk next about the then compose method. Then compose syntactically looks very similar to then apply, but it has a really important difference. Like then apply, it applies a function action to the result of a previous completion stage. So there's a function that gets applied to when the previous completion stage finishes. The difference here is that this returns a completable future that contains the results of the action directly rather than a nested completable future, which is what you'll end up with then apply. You can end up with nested completable futures as opposed to non-nested completable future results. So then compose as a method has semantics that are very similar to flat map on a stream or flat map on an optional. And what I mean by that is that these flat map methods do denesting. If you recall what flat map did, it would take, say, a stream of lists of items and return that as a stream of items. So it denests things. So if you're going to use then compose and you have 2 completable futures, you'll end up with a single completable future when you're done. Were you to use then apply, you'd end up with nested completable futures when you're done, which is often more unwieldy, although still usable, it's just more unwieldy. So when do you use one of these versus the other? Well, the main distinction is you typically would use then compose for asynchronous actions that take a while to run and that return a future, whereas then apply is used for things that are going to be quick synchronous actions that return a value, not a future. So let's take a look at an example here In this case, we're going to have a function which we call reduce and multiply fractions. And you can see that it takes its first generic parameter is a big fraction. I just abbreviated it to be BF because it gets too long for the slides otherwise. And the second part of the generic function is a completable future to a big fraction. And you can see what the reduce and multiply fractions function does. It's a lambda function. It calls completable future supply async and goes ahead and reduces the big fraction. So it's going to go ahead and reduce the unreduced big fraction. And so what it's trying to do there, of course, is it's trying to return a completable future to the results of the reduction. Okay, so far so good. What we're going to do then is we're going to go ahead and use then compose to take the reduced big fraction, and then we're going to go ahead and asynchronously take the result of that fraction and multiply it by some constant or some value. And the main thing to note here is that then compose, as you can see in the diagram, the highlighted return value from then compose is a completable future to a big fraction, not a completable future to a completable future to the big fraction. And why this distinction is important is because if we used then apply instead of then compose, the return value from then apply would be a completable future to a completable future of type big fraction, which, while doable and will work, is unwieldy because nesting gets to be a big mess very quickly. Whereas this approach using then compose lets you keep a single level of completable future as opposed to having nested completable futures. So that's the primary motivation for using then compose instead of then apply. Now, just to be interesting, and this is actually relevant for your assignment number 3, another way to do this, rather than using then compose in conjunction with another call to supply async, as you can see down here, we have a second call to supply async with then compose. What you can also do is you can use then apply async, which is the async variant of then apply, and then you can pass in the particular computation you want to be performed in a background thread, in a different background thread in the common fork join pool, or whatever pool you designate it, because you can provide your own executor if you want to. So what this does is this will return just a completable future, but it'll arrange to run it in the background. So you'll find in your assignment, your programming assignment number 3, this feature comes in very helpful. So then apply async can give you that flexibility. And you also see there's a then compose async as well, which also gives you some good flexibility. So then apply async can often be used to replace then compose supply async nestings, and you'll have a need to do that. Another thing you can do here, this is kind of an idiom, if you do in fact use supply async on something that returns a completable future, and you want to avoid having nested completable futures, then you can use the then compose method together with function identity. And this is a way to flatten the return value so it only has a single level of completable future nesting. So this is a little bit more esoteric, but this particular idiom turns out to be handy in some cases where you want to avoid calling join. As a general rule of thumb, you want to try to avoid calling join on a completable future if at all possible, because you end up with extra overhead by blocking in that case. So using tricks like then compose with function identity, or using tricks like then apply async and so on and so forth, or then compose async, allow you to not have to call join, which causes undue blocking in your code. So you can also use then compose async, and then compose async can be used to avoid calling supply async yet again in a chain where you've got methods that return completable futures. So again, if you have highly asynchronous code, and you'll have some examples of that in programming assignment number 3, where you've got methods that return completable futures that run a long time, then you want to use then compose async in order to avoid having nested calls to these these completable futures, where you have completable future to completable future. Again, you'll start to realize this as you work through the code examples. And I think you probably want to come back and rewatch this set of slides, because it's very subtle, the difference between then compose and then compose async, and then apply async, and then apply and then compose. It's a little bit mysterious at first, but the good news is once you practice it and you let your compiler tell you when you need to use those methods, it'll start to make some more sense. The third method we're going to talk about that's triggered by completion of a single stage is the then except method. And it takes a consumer action that handles the results of the previous stage. So it consumes it. It basically sort of takes the end of the pipeline, if you will. This action behaves as a callback that needs some kind of side effect to have an output. And notice it returns a completable future to void. So that means there's no return value. As a consequence, then except is most commonly used at the end of a chain, a fluent chain of dependent actions, as the very last one, or typically the last one. And as you can see here, what we're going to do in this particular case is we submit a supplier lambda to supply async, and that gets run in the background to do the reduction. We then convert that into a mixed string. We convert the improper reduced fraction into a mixed fraction using then apply with the big fraction : to mixed string method reference. And then the final thing we do in that chain is we take that mixed string and we go ahead and accept it. And the action that's passed to accept in this case is the println method, which has the side effect of printing the result. So system.out : println is a method reference that's going to have a side effect. It's a callback, effectively, that has the side effect of printing the mixed string to the standard output. But you don't get a value back from here. You get a completable future back. So if you needed to, of course, you could join it if you needed to, but you can't get the value back through then except, because it returns a completable future to void. This all sounds very esoteric and confusing sometimes when you first hear me talk about it, but once you start to apply these things in practice, you'll see how it works. The reason why then except is problematic is if you're not careful, it can lead to something called callback hell, which is a common problem that people run into with JavaScript code. And if you use JavaScript, you can have callback after callback after callback that becomes deeply nested, and it's commonly referred to as callback hell. You can read more about callback hell in JavaScript here at this link. You would have the same problem with then except if you only use that, because you'd have to nest the callbacks. That's why you typically want to use then except, or then compose, or then compose async, or then except async to avoid callback hell. So that's the end of the overview of our single stage completion methods. And they're important to understand. You'll use them quite extensively in the program for programming assignment number 3.